Before we begin, I want you to forget for a moment that you're in mathematics class. Don't think about formulas. Don't think about solving for x, and please don't think about an examination. Today, I want you to become an observer because sometimes the most beautiful mathematics is mathematics that we don't immediately notice. Look at this sunflower. It looks beautiful, right? But here's the question: why? Why does something as simple as flour look so organized? Why aren't the seeds scattered randomly? Why do they seem to form these beautiful curves? It is simply nature being beautiful, or is there a mathematical pattern hiding inside? Today, we're going to investigate it. And by the end of this lesson, I want you to look at sunflower and see something you couldn't see before. So let's begin with something very, very simple. Don't calculate anything, don't write anything yet. Just look. Take a second, look at the center of the sunflower, look at the seeds, look at the curves, look at the way everything seems to spiral outward. Now, ask yourself two questions. What do you notice? And what do you wonder? Maybe you notice that the seeds form spirals, right? Maybe you notice that the spirals seem to go in different directions. Maybe you notice that the flower doesn't look random at all. And maybe you're wondering, how does a plant know how to do this? That's a very, very good question. Today, we're going to discover that the nature can be full of mathematical patterns. Now, let's travel back in time, long before smartphones, long before calculator, long before Google. There was a young Italian mathematician. His name was Leonardo of Pisa, but he became better known by another name, Fibonacci. And interestingly, one of the mathematical patterns connected to his name began with something that sounds almost like a children's story: rabbits. Yes, rabbits. Imagine someone asks you if you start with one pair of rabbits and rabbits reproduce, and how many rabbits might you have after several months? It sounds simple, right? But when Fibonacci explored this problem, he discovered something fascinating. A number began to appear. There is a pattern, and that pattern eventually became known as the Fibonacci sequence. So let's slow this down. So imagine we begin with one pair of rabbits. So let's imagine this is a one pair. So basically, when we say one pair, pair two, okay. So at 0 month, so we have one pair. At 1 month, we still have one pair. Then something happens by month two. So month two, we have two pairs. By month three, we have three pairs. And by month four, we have five pairs. Now, look at the answer. Look at the pattern. We have one pair, then two pairs, then three pairs, then five pairs. Now, I want you to predict what comes next. Okay? So take a few seconds, think by yourself what number comes next now. Okay? So let's reveal now the answer. In our classroom, we will reveal that answer. The question is, what comes next? Now, look carefully at the sequence. So we have this Fibonacci rule. The Fibonacci rule is the x of n equals x of n minus 1 plus x of n minus 2. So I want you to have this given. The given is the x of 0 is 0. Okay, so just like in the first month, wow, we don't have value. So x of 1 is 1. So the sequence is 0, then 1, then 1, then 2. So how does this number being observed? So when you add 0 to 1, the answer is the next number. Okay, it's 1. When you add 1 to the next number, the next number is 2. When you add 1 to the number 2, what do you think is the next number? 3. When you add 2 plus 3, the next number is 5. When you add 2 and 5, the next number is 8. Same thing will happen. 5 plus 8, that is 13. 13 plus 21, 8 plus 13 is 21. 21 plus 13 is 34, and so on. So you get the pattern. It's just like in the rabbit story earlier. Okay, so one pair of rabbit plus one pair of rabbit is two pairs of rabbit. Two pairs plus one pair, that is three pairs. Three pairs plus two pairs is five pairs. Okay, so that's an interesting observation from the Fibonacci rule. So, but in this case, I want you to write down here this Fibonacci rule because that is very, very important. Okay, so now we want to find the ninth term. Okay, so here we have the x of 9. We're going to look for the ninth term. By the way, the 9 here will represent the term, the number of term. For example, x of 2, we're looking for the second term. So now, let's see whether we can use the rule. Okay, so ninth term of number is equal to the previous number, which is the 8th term, plus another previous number of the 8th term is 7th term. Okay, so previous number niya is 8th term, and the previous number is 7th term. Now we need to find the sequence here. So step 2, the 8th term is 21, right? The 7th term is 13. So if you are looking for the if you're looking for the numbers, so this is we have 0, we have 1, 1, 2, 3, 5, 8, 13, 21, 34. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So we'll start the term with 1. Okay, so this is the first term, second term, third, fourth, fifth, sixth, seventh, eighth. Okay, so we have 8th term, that is 21, and the 7th term, that is 13. Okay, so we will be adding them. So add them, 13 plus 21, that is equal to 34. So step 3 is the x of 9 is 21 plus 13, or the 9th term would be 34. Okay, so I hope you get the pattern. So by the way, this is the thing that I write here in our board. Okay, so this is the Fibonacci sequence. So take note, I want you to notice na hindi tayo nag-start sa 0, pero nag-start tayo dito sa 1. Okay, so ito yung first term, second term, third, fourth, fifth, sixth, seventh, 8, and 9. So 8 ito at saka 7, pinag-add yan, that is para makuha natin yung 9th term dito. So now, let's find out what will happen for the 11th and 12th term. Okay, so I want you to show our solutions vertically. So when we are looking for 11th term, of course, we are looking, or we will be adding the two previous terms, so which is the 10th term and the 9th term. Okay, so for us to get the 10th term, we have 10th term is 55, 9th term is 34. So if you follow the sequence here, okay, so just continue this one, 34 plus 21, that is 55. This is the 10th term. So 55 plus 34, that is 89. Okay, so that's the pattern that you will be doing here. So we have 55 plus 34. Again, 55 is the 10th term, 34 is the 9th term. Now we're gonna add them both for us to get the 11th term. 55 plus 34, that's going to be 89. Okay, so that is the 11th term. What about the 12th term? For us to get the 12th term, just use the 11th term. Okay, is 89, and the 10th term, that is going to be 55. Okay, add them together. 12th term is equal to 89 plus 55. Yan ay 144. Okay, so just want you to remember, each term after the first two is the sum of the two preceding terms. Okay, so ito po yun. So remember our sunflower. Let's go back to it, because the Fibonacci sequence isn't just something we write on paper. Patterns related to Fibonacci numbers can be observed in many natural form. I want you to look at this: the sunflower, the shell, the pineapple, the fern. And notice, we're not saying that every spiral in nature is literally a Fibonacci sequence. What we're doing is looking for mathematical patterns and relationships that help us describe what we see. That's the exciting part. Mathematics give us a language for describing patterns in nature. So now, I want you to become, I think, detectives. Look carefully. Ask yourself, what patterns do I see? And what might this pattern appear? Okay, so that question is an open ended question, and I want you to observe these four nature secrets. Okay, and I want you to write on paper what is your observation. Okay, before we go any further, let's make sure that we have one small mathematical skill ready because we're about to compare ratio later on. So suppose we have x over 4 equals 6 over 8. What we're going to do is we can cross multiply this to find the x. Okay? So again, if there is a 2 fraction here, ang pwede mong gawin is to cross multiply it. So the 8 here in the denominator shall be multiplied to x. So it will become 8 times x. Okay? And the 4 here in the denominator shall be multiplied to 6. And that is equal to 6 times 4. Okay, I think I have a solution here. So I'm going to erase it. I'm going to change it with my number. So we have 8 over 4 equals 6 over 8. That is 8x equals 24. Again, so how do you get the 24? 4 times 6, that is 24. Then we get to divide both sides by 8 for us to isolate x here. Para matira lang si x. That is equal to x equals 24 divided by 8. That is going to be 3. And the x here is 3. Now, we arrive at the heart of today's lesson, and that is the golden ratio. So, the given here, okay, so a plus b, that is going to be 100. So, this part and this part, when we add them, that is going to be 100 units. So, ibig sabihin, we will let a be x, and then b would be going to 100 minus x. Again, dito papalitan ko lang si a ng x, at para magkaroon tayo ng b, gagawin natin siyang 100 minus x. So, ano bang ibig sabihin nito? So, yung 100 kasi, that is the whole. Okay, yung kabuuan. Yung larger part, yung kaninang x o yung a, that would be the larger part. Ito yung malaking part. Okay? Again, ngayon, dating ang pangalan niya is a, pero pinalitan natin siya ng x. The smaller part is yung kabuuan na 100, pag-minus tayo ng larger part, ano na yung lalabas? Siyempre, yung mas maliit na part, which is this one would be the smaller or mas maliit na part. Okay? So with that, we can create an expression here. Yung whole over larger, yung kabuuan, pag dinivide mo doon sa larger, parehas lang naman daw sa larger pag dinivide mo sa smaller. So yun yung ratio nilang dalawa. Okay? So, ngayon, alam natin yung whole, di ba? The whole is 100. Okay? The whole is 100. Over the larger, dating a, magiging x na siya. And that is equal to the larger, x ulit, over yung smaller, yung kabuuan, nag-minus ka ng larger part, kaya siya nagkaroon ng 100 minus x. Okay? So, ang goal natin dito is to just solve for x. Again, kopyahin natin yan dito. So, para ma-solve natin yung x, kanina ginawa natin yung strategy. Ang strategy na gagawin natin is to cross-multiply. So, the 100 over minus x here, multiply it to 100 there. So, we have 100 times 100 minus x equals x times x, that is x squared. Okay? So, 100 times 100, that's going to be 1 or 10,000, right? Minus 100 times x. Okay? That is going to be negative 100x equals x squared. Okay? So, ang gagawin natin, ililipat natin lahat muna, siguro ito. Ilipat ko na muna ito sa left-hand side kasi positive na yung x squared natin. No? So, we're gonna transform or transfer here these two terms. Pero hindi tayo basta-basta mag-transfer, no? Ang anumang kabaliktaran ng negative 100, that is positive 100x. So, ibig sabihin, nag-add ka both sides ng 100x. Ito naman, ang kabaliktaran ng 10,000 is negative 10,000. Ibig sabihin dito, magsusubtract ka ng 10,000 both sides. So, magiging ano na yan? So, magiging x squared plus 100x minus 10,000. Okay? So, that's it. At sa kabila, meron tayong 0. Pero para mas maging maayos yan, ang gagawin natin dito, siguro ipagpapalit, swap lang natin si 0 at saka yung term na to, yung 3 terms na yan. So, magiging ganito na siya. Okay? Again, pinagpalit ko lang muna. Ilagay ko sa kabila yung 0. No? At ito yung magiging term or magiging quadratic term natin. So, x squared plus 100x minus 1,000 equals 0. Okay? So, now, pwede mong gamitin ng calculator mo para mahanap mo yung x dito. If you're familiar sa quadratic formula, the quadratic formula is x equals, kung naalala nyo pa to, so negative b plus or minus square root of b squared minus 4ac over 2a. Kung naalala nyo pa yan, yan ang gagamitin natin para sa part na to. Ayusin natin muna. Okay? So, what we're going to do is to find the a, the b, and the c. A here is 1, b in second term, may x, that is 100. C is negative, kakasya pa ba? 10,000, negative 10,000. Okay? So, tapos, type mo na yun sa calculator mo, makakuha mo to. No? So, x is approximately, makakuha mo yung positive side, huwag na kunin yung negative, 61.8. Again, type mo lang ulit yan. Palitan mo lang yung letter A, B, C dyan. Yung B, palitan mo ng 100. Yung B squared, yung B dito, palitan mo ulit ng 100. Yung A, palitan mo ng 1. Yung C, palitan mo ng negative 10,000. Tapos over 2 times A, 1 ulit. Ang lalabas na sagot dyan, dalawa. Isang positive, isang negative kasi may plus or minus dito. Pero dito, ang i-apply lang natin is yung positive. Kasi bawal yung negative. So, ibig sabihin, ang lalabas dyan is approximately 61.8. So, ano ba itong 61.8 na to? That is the larger value, larger part. Yung 61.8, yan yung x. Yan yung letter A natin. So, ang A natin ngayon ay equal sa x. That is approximately 61.8, yung mas malaking part. So, para makuha mo daw yung smaller part, kailangan mo daw i-subtract yung kabuuan sa larger part, which is x. So, we have B is approximately 100 minus 61.8, yung larger part. Makakuha mo ngayon yung mas maliit na part na 38.2. Okay? So, if you want to check the golden ratio, yung whole whole is 100 over larger, okay? Equal daw yan sa 100. Tama? Over 61.8. Then, that is approximately, type mo sa calculator yan, 100 divided by 61.8, that is 1.618. Okay? So, just verify kung tama tayo. Parehas tayo ng sagot. Now, try naman natin itong larger over smaller. Sabi parehas lang sila eh. Tignan natin kung parehas lang sila. Kasi nakuha na natin to. Ang sagot is 1.618. Try natin si larger over smaller. So, si larger dito is 61.8. Tama? At yung smaller part is 38.2. Type it in your calculator. Let's try if we have the same answer. 61.8 divided by 38.2. That's approximately 1.618. Coincidence? No. This is the golden ratio. Okay? So, both ratios are approximately equal. Yan po ay golden ratio kapag nangyari po yon. So, here we have the visual check. 100, yung 61.8, then 38.2. Kapag pinag-add natin 61.8 kay 38.2, that is equal to 100 units. Right? So, therefore, A is equal 61.8, B is equal 38.2. Ang golden ratio natin ay 1.61.8. Okay, that is the golden ratio. So, may tanong na ako sa inyo eh. Kapag ginawa natin tong golden ratio test na to, alam natin na 1.618 ang lalabas. So, conclusion natin yan ito. Okay? Yung part A na yan, yung mas malaking part is 61.8, yung mas maliit na part is 38.2. Sabi ko nga kanina, pag pinag-add mo daw si A plus B, that is equal to 100. That is good. Tama naman yung ating sagot. Okay? Pero you know what? Hindi sa lahat ng pagkakataon, nag-work siya. Kagaya ng given na to, A equals 20, tapos B equals 15. Eh, meron ka ngayong A dito na 20. Dinivide mo daw sa 15. That is approximately 1.33. Okay? Tapos, yung 35 over 20, ang ginawa natin dyan, pinag-add natin si 20 kay 15, yung 35, divide mo sa larger part, okay? So, that is 20. That is 1.75. Okay? So, since 1.33 is not equal to 1.75, hindi kagaya ng ginawa natin kanina, they are equal. Yung sagot natin, hindi yan golden ratio. Okay? This is not a golden ratio. So may certain number lang po na pwede natin gamitin para dito. Which is, ito nga, yung 61.8 over 38.2. So, ayun nga, di ba? Yung A over B. Tapos ito, yung 100. Pag pinag-add natin itong dalawa, 100, di ba? Tapos di-divide natin sa larger part. Parang ginawa natin dito, hindi naman siya umubra. This is not a golden ratio. So, ngayon, let's try out the Fibonacci sequence and the golden ratio. Kanina, ano bang yung mga Fibonacci sequence? We have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Ginagawa natin, ina-add lang natin yung previous dun sa previous niya. So 3 plus 5 is 3 plus 2 is 5, 5 plus 3 is 8, and so on. Okay, 89 plus 55 is 144. What is the relationship between the Fibonacci sequence and the golden ratio? Let's try nga yung 13 over 8. Yung 13, dinivide natin sa previous, which is 13 over 8. So, ang sagot dyan is 1.625. Okay? You can try 34 naman. Pag dinivide mo sa 21, what is the answer? 1.619. Now, try 89 divided by 55. 1.618. And 144 divided mo sa 189, or sa 89, that is 1.618. So, kung napapansin nyo yung pattern, makikita nyo po na palapit ng palapit siya sa golden ratio. That's their relationship. The ratio get closer to the golden ratio, which is 1.618. Okay? So, kung i-verify mo, tignan mo mabuti sa calculator mo, oo nga, lahat ng Fibonacci sequence, kapag dinivide sa previous number niya, parang lumalapit siya approximately dun sa golden ratio. That's the perfect ratio that we have. So, larger Fibonacci sequence divided by previous Fibonacci number, not sequence number, yan po, mapapunta po kayo sa golden ratio. As Fibonacci numbers becomes larger, makakuha nyo po yung 1.618. Okay? So, I hope you get the relationship between Fibonacci sequence and the golden ratio. So, let's have a gallery walk. I want you to take outside the mathematics books because mathematics doesn't stop at the screen. Look at this image: sunflower, a pine cone, a shell, a galaxy, ancient architecture, different objects, different places, different scales. But they all make us ask the same question. Is there a mathematical pattern here? Your task is simple. Because a pattern detective, don't just look at the picture. Look inside the picture. What repeats? What spirals? What grows? What is proportional? What seems organized? And most importantly, what evidence do I have? Okay, so identify one mathematical pattern you notice, explain why you think it is pattern, and then switch. Remember, observation first, explanation seconds. Evidence always attached here. So, the task is find mathematical patterns in each picture. So, you've now discovered the basic relationship. You've calculated Fibonacci's numbers. You've tested ratios. You've explored the golden ratio now. And I want you to take this mathematics beyond this classroom. For your assignment, we work with, let's change this one. Let's change it to, let's make it 15 and 16. Okay, so since we already accomplished the 11 and 12, let's try to find the 15th term and the 16th term. So make sure you show your complete solutions, then apply the golden ratio test. Then don't simply write, yes, it is a golden ratio. Show the calculation, show your evidence, then submit your work in the 1/2 sheet of paper, okay, of yellow paper. That's it. Do you have any question? If you have a question, I want you to write the things that you've learned here in our session number 2 in the comment section if you can access it. So thank you for listening. I hope you really understand and appreciate this session number 2. Thank you for listening, class. See you in our classroom.